Example number 8 is an interesting problem. It says if all rectangles inscribed are put inside a circle of radius 1, guess which has the largest area, and then guess which has the largest perimeter. Well, the book just quickly passes over this, so I actually want to go through what's going on and how we can prove that the answer is actually a square for each of those problems. So let's go ahead and draw out a circle who does have a radius 1. So let's say we have a circle here, and we put in some particular rectangle. It's not going to be perfectly drawn, but you'll get the idea. Okay, so there it is. And the thing that we know is that the radius coming out is 1, so that means that this length right here is a length of 1. Okay. Now, what we don't know are the sides of the box. We do know that these sides are the same, and that these sides are the same. So let's see if we can find a relationship between x and y, okay, using the radius value here, so that we can go ahead and calculate both the area and the perimeter using some kind of formula. So let's look at doing the following. If we extend this over here, then what we get is a triangle over here, a right triangle specifically, where we've got x, y, and the hypotenuse value of 2. So that means if we take x squared plus y squared, we get the value 2. Or in other words, that means if we want to solve for x in terms of y or for y in terms of x. In fact, I think it's going to be better to take y and solve it in terms of x. So what I mean is, let's get y by itself. So y squared, you can do it either way. So y squared will be equal to 2 minus x squared, or y is equal to plus or minus the square root of 2 minus x squared. Now, the thing that we have to be careful on here is that for y, we don't want it to be negative, we want it to be positive, because it's a distance here, it's a length. So we're just going to use the positive square root of this guy, just like that. Okay, now what I have is, instead of having y over here, I now have this side length right here equal to this. So we can do two different problems. We can ask for what is the area as a function of the side length x. Well, area is the length times the width, so it'll be equal to x times this guy. And then perimeter as a function of x is just equal to the addition of these four sides. So the perimeter would be equal to 2x plus 2 times the square root of 2 minus x squared. So now let's go ahead and take a look at those two different functions in terms of x. Well, we can look at them graphically, okay, which I think is not a bad idea to do. So let me rotate my computer around here. Okay, so let's go ahead and delete that guy out. So let's look at the area. It's x times the square root of 2 minus x squared. So that'll be x times the square root of 2 minus x squared. Now, of course, my dimensions are off quite a bit. Our x values, we know, can be as low as 0, okay, and it definitely can't go over 2, okay? And we know that the y values also have to be the same. They shouldn't go less than 0, but they shouldn't go more than 2, just like that. And so if we take a look at our graph, this right here is the area curve. And notice that it has a maximum up here, and it looks like at 1. Now we're going to check that out algebraically using a little bit of calculus. And so what I'll do is I'll find what is, let's do it in the same color, what is a prime of x? Well, the derivative of this is found by the product rule. So it's the derivative of the first times the second plus the derivative of the second. Now here's where we have to be careful. The derivative of the second is going to be 1 over 2 square roots of 2 minus x squared times the derivative of the inside, which is minus 2x, times the original function. So this will be 2 minus x squared plus, now the 2's are going to cancel. I'll be left with a negative, so let's pull that guy out. Just like that. Okay. And then, let's see what we got left. We've got x squared in the numerator because it's x times x. And then in the denominator, we have 2 minus x squared. And of course, we want to set that equal to 0 to find the critical values. So let's go ahead and look for those critical points. So this means that the square root of 2 minus x squared times the square root of 2 minus, well, I'll write it like this. This should be equal to this. If I move this piece over, I get this. Now if I multiply both sides by that, by this denominator, I get 2 minus x squared. Now we should be careful with this right here. Okay, should be careful with this because if x falls out of the range, like if we let x become, oh, I don't know, 3, well then this becomes negative. But of course we can't let that happen in here because of the way that our function's defined. So we're not going to worry about absolute values at this point. And if we move things over, we get 2x squared is equal to 2. So of course x squared is equal to 1, which implies that x is plus or minus 1, but we know that it can't be negative. So we have x equals 1, which was the value here that we found. Okay, so what does that tell you about the object? Well, going back up here, if x is 1, well, then this length also has to be 1. Okay, so if we have a length coming over at the top that's 1, we also must have a length coming down here that's also at a value of 1. And you can tell that that's the truth because it's going to be the square root of 2 minus 1 squared. 2 minus 1 squared is 1, square root of 1 is also 1. Okay, so we've got that. So now we've shown that if both sides are of equal length of 1, okay, then we end up with a square inside here, and the square is the object that maximizes the area. Okay. So now let's go ahead and look at the perimeter. Well, P prime, let's go ahead again and graph that guy out. Well, I'm going to graph out P, not P prime. Okay. So P is equal to 2x plus 2 times the square root of 2 minus x squared. Okay. So we end up with this guy right here. Okay. But now let's go ahead and talk about perimeter. Well, we know that for the perimeter, our x values have to go again from 0 to 4. And the y values, that's perimeter. It's not the y length. So the perimeter, let's go from, we can't have a 0 perimeter inside that circle. I will put a 0 in here though, just so that we can get a little bit more of the graph. And let's say we go up to like 8. Okay, well there it is. Now we can go around with it. Okay, now what we notice, let's zoom out a little bit. Oops, I went way too far. Okay, what we're going to notice is that we come over here and go up and we get this value, which is our perimeter, which is 1 unit over, 4 units up. So let's go ahead and check to make sure that that's the solution here. So P prime is 2 plus the derivative of this guy is going to be 2 times 2 over the square root of 2 minus x squared times the derivative of the inside, which is going to be negative 2x. So that'll be 2 plus negative 2x over the square root of 2 minus x squared. We'll set that guy equal to 0. So that'll be 2 is equal to 2x over the square root of 2 minus x squared. So 2 square roots of 2 minus x squared has to be equal to 2x. The 2's cancel out, so that means the square root of 2 minus x squared has to be equal to x. Now if we square both sides, we have to be a little bit careful when we square both sides because x could be negative, but here we clearly know that x is not negative because it's a positive length. So we get x squared is equal to 2 minus x squared, and again we move this guy over, so we end up with 2x squared is equal to 2, so x must be equal to plus or minus 1, but again we know it's positive 1 because our length can't be negative. So that again gives us a square value embedded in here. So if we want to maximize area or perimeter, we need to make it a square. That's much more insightful than what the book gave you.